chemistry students. Today we're going to finish up our stoichiometry unit by reviewing for the stoichiometry test that we're going to be taking. So, first of all, I'm going to tell you a little bit about the test, and then we'll go over the stoichiometry review and actually solve some of those problems. So, before actually doing watching this video, I'd prefer if you actually did the review yourself, time yourself when you do it, and give yourself about 15 minutes to do that in order to kind of get the pacing down. So, first of all, what are our objectives for this unit? So, first and foremost, I can perform stoichiometric calculations using the dimensional analysis method. If you can do this, you're going to be just fine for the test. The next objective is to identify a limiting reactant conceptually and mathematically. So be able to, if I give you a scenario, be able to calculate and find out which one is the limiting reagent, which one's the excess reagent, which one determines how much of your product can be produced. And then finally be able to demonstrate an understanding of percent yield and calculate percent yield of a situation. So if I give you a lab situation, so-and-so started with this many grams of their reactant, they produced this much of their product, you can calculate a percent yield. The thing that I wanted to point out for this, to do a limiting reactants problem and to do a percent yield problem, you need to be able to do a stoichiometry problem. So you can't do the second two objectives if you can't do the first one. So if you cannot do a simple stoichiometry problem, we got some problems. Alright, so let's take a look at what the test is going to be. The test is going to be broken up into three passages. Each passage kind of describes a situation, and then after it describes a situation, there's going to be a few problems testing your stoichiometry based on that. Typically, for those passages, there are going to be two just kind of plain stoichiometry problems, 1% yield problem, and one limiting reactant problem. Out of the entire test, there's only 10 questions. So when you're pacing this out, you have about you'll probably have, by the time we get things passed out in class, about 45 minutes to take the test. So that gives you about 4.5 minutes per question to do the stoichiometry. That should be plenty of time for you. However, you might find that if you're stuck on a problem for a long time, that time really runs out on you quick. So for each passage, there's typically going to be two stoic problems, 1% yield problem, and one limiting reactant problem. In there, I eliminated 1% yield problem, one limiting reactant problem, just to make sure you'd be able to finish the test. So not every passage will have a percent yield or a limiting reactant problem. Alright, our stoichiometry review looks just like our test looks. So there's a passage to read, there's a reaction, and then there's some questions based on that. So let's take a look. The first question here is just a plain stoichiometry problem. So the question here says, looking at past energy bills, in the month of January, the school typically uses 10,000 moles of methane to heat the school. How much carbon dioxide in grams is produced in January? So what we're going to do, we're going to set up a stoichiometry problem. It tells us that we start with 10,000 moles, that's a lot, of natural gas. To heat the school, how many grams of carbon dioxide are we going to find? So, in our stoichiometry problem here, we start with 10,000 moles of our CH4. Now, we're already at moles, so we don't need to do a gram problem. We can just go straight to our moles of CH4, 2 moles CO2 step. I'm going to use my coefficients from the balanced equation there. They both happen to be 1. And then it's asking me for grams of CO2, so I'm going to change moles of CO2 into grams of CO2, the molar mass of CO2 being 44.01 grams. So we go ahead and calculate that. That should be 44,010 grams of CO2 produced in the month of January at the school. So this was the first question for that passage. It related to what it was talking about, but all the information that we really needed here was inside the question itself. Alright, question number 2. There's a small natural gas leak into one of the school's bathrooms. You walk into the bathroom and you go to light a match to burn the extra methane off. After the reaction, there were 100 grams of water produced. How much methane in grams was leaked into the bathroom? So, setting up our problem again, what we're being given is that we produced 100 grams of water. So, how many grams of methane were produced? We're going from grams of one substance to grams of another. So we start with our given, 100 grams of H2O. So I have to get rid of grams of water to get to moles of water. So our ratio there, 1 mole of water is the molar mass, which is 18.02 grams. So now we're ready for our moles to mole step. So moles of water and moles of methane. So our ratio here from our balanced chemical equation, methane's 1, water is 2. And then our last step is going to be going to moles of methane. So we did this in the last step. No, we didn't use methane, we used carbon dioxide. So we have to recalculate our methane here. So 1 mole of methane should be 16.05 grams of methane. So you go ahead, you multiply across the top here, 100 times 1 times 1 times 16.5 divided by 18.2 divided by 2. And at the end, you should find that we had accidentally released 44.53 grams of methane into the bathroom. When you lit the match, you got rid of it. So again, that's a just plain stoichiometry problem. Question number 3 here. There is only 700 moles of oxygen available to the furnace room on a given day, while only 10,523 grams of H2O is produced. What's the percent yield of the reaction? Now here's the great thing about percent yield problems. If I'm going to ask you a percent yield problem, I need to ask you, what is the percent yield? So we know right here that we have a percent yield. So remember that our percent yield is going, the equation for that is actual over theoretical times 100 is equal to your percent yield. So what we need to find, the problem will give us this value that we have right here of H2O. That is actually the actual. So what we need to do is we need to calculate the theoretical. We should find out how much H2O should we have produced if we had 700 moles of oxygen. So we're going to set up a Stoich problem. 700 moles of oxygen. Let's find out how many grams of water we should have made. So we're going to use our ratios again from our balanced equation. And then change this to grams. So you go ahead and finish this calculation out. You should get 12,614 grams of water should have been produced. So now for our actual calculation, 10,523 grams of water divided by 12,614 grams of water times 100 should give us a percent yield of about 83.42%. So that's how we're going to calculate our percent yield. Remember that the only way to get a theoretical yield for any kind of percent yield problem is always going to be through doing a Stoich setup. Alright, and then the last question here. The furnace room has limited ventilation, and you determined about 700 moles of oxygen can be used by the furnace on a given day. During a very cold winter, the school purchases 300 moles of methane every day. How much CO2 can be produced in grams every day? So if we look at the question and what we're given, it tells us that we have 700 moles of oxygen, and it also tells us that we have 300 moles of methane. So what we need to do is find out which one produces less of the carbon dioxide product. Whichever one produces less is going to be the limiting reactant. So we'll set up 2 Stoich problems and solve this. We have 700 moles of oxygen. Let's find out how much carbon dioxide we can make. So we're going to use our mole ratios right away. So this first one is from oxygen. That tells us we can produce 15,403.5 grams of CO2. For our second problem here, we start with 300 moles of the CH4. And so this one is going to give us 13,203 grams of CO2. So looking back at our problem here, it looks like the smaller quantity is being produced by the CH4. So this is going to be our limiting reactant, and the oxygen is going to be our excess. Which, I guess for our school is a good thing, because if we're buying more methane than we can actually burn because of oxygen, then that's not financially very smart. So here's the quantity that we can produce. So this would be the answer. This is how much can be produced. We have enough of the oxygen to actually make more, but we run out of the methane in the process. So that's how much can be produced. You should know that whatever your limiting reactant is going to determine how much of your product can be produced. Alright, so these same types of things are going to be on your test. You're going to have similar passages, however, about different topics. Then you're going to be given a series of questions based on that topic to try and solve the stoichiometry problem. As far as pacing is concerned, for doing these 4 problems, if it took you more than about 15 minutes to do that, you're going to be a little bit tight on time, because like I said, there's going to be 3 passages to do. However, 2 of the passages are only going to have 3 questions, not 4. So give yourself about 15 minutes. That gives you a little bit of time to go back, check your work over, or maybe get stuck on one and take a little bit more time, and so forth. Alright, good luck studying, everybody. Keep practicing.